Connecting to an IoT device using a password is inconvenient and less secure. Today I will show you how to configure an SSH key so you can log in quickly, securely and without entering a password. The SSH key mechanism uses asymmetric cryptography, meaning two related keys, a private key and a public key. The private key stays on your computer and should never leave it. The public key can be safely placed on the remote device. When you attempt to log in, the server doesn't ask for a password. Instead, it verifies whether you possess the corresponding private key. This happens through a process called challenge response. The server sends an encrypted challenge that only can be correctly signed with your private key. If the signature matches, access is granted. Importantly, the private key is never transmitted over the network. Only the mathematical relationship between the keys is used. This means that even if someone intercepts the network traffic, they will not gain access to your device. An additional layer of protection is a passphrase, which secures the private key itself. Even if someone obtains the key file, it remains useless without the passphrase. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. Now we will generate an SSH key pair on the main computer. This command creates the key using the ED25519 algorithm, which is modern, fast and secure and recommended over the older RSA. After running the command, the system will ask where to save the key. If you don't have special requirements, simply press enter. The keys will be stored in the SSH folder inside your user directory. Next, you will be prompted to set a passphrase. This is an additional password that protects the private key. It is not mandatory, but it significantly improves security. When the process finishes, you will see two files. This is the public key that we will add to the IoT device, and this is your private key. Never share it. Now that the key has been generated, it is time to add it to the remote device, for example, a Raspberry Pi. This is the step that actually enables passwordless login. After running the command, you will be asked to your password one last time. The tool will automatically copy your public key and save it in the authorized keys file on the device. Time to verify that everything works correctly. In the terminal, type SSH user at device IP address. If the configuration was successful, you should be logged in immediately, without being asked for a password. Once passwordless login works, you have a secure setup ready for remote work with your device.